So we started working on a project where we learned how to manipulate dormant twigs, winter twigs of apples, to the point where we could remove all their freezable water without killing them. If there's no freezable water left, there's no capacity to form ice crystals and cause damage under cold conditions. Then we learned how to process those twigs and those buds so that we could pass them through colder and colder temperatures, eventually putting them in liquid nitrogen. Liquid nitrogen's at minus 196 Celsius. At that temperature, there's little or no metabolic activity. Nothing is happening. And especially if you've removed all the freezable water, there's no opportunity for biochemical reactions to occur, no opportunity for any damaging reactions to occur. So theoretically, the material should be stable then for many, many years. And that's why I came to the National Seed Storage Lab after doing work on a preliminary basis at the University of Saskatchewan in Canada, where we developed a method following up on some work that was done in Japan years ago, where we learned how to remove this water, how to process them so we could put them in liquid nitrogen and get survival. And so the point then was to bring that knowledge, technology to Colorado State University, which was then called the National Seed Storage Lab, now the National Plant Germplasm Preservation Center, and start a program to put these dormant twigs into liquid nitrogen. So we had processed, in collaboration with Cornell University, 600 different genetic lines that went into liquid nitrogen, and as far as I know are still there. They've been sampled after we had a program of 5, 10, 15 years, and I believe there was another sampling 25 years after they were put into nitrogen to determine if they're still alive. And indeed they were. They survived. So, there are cold tender types of other fruit crops that are not so easily manipulated, but the group that we chose that we thought were the genetic core of the world's apple collection, were preserved in liquid nitrogen and still are in liquid nitrogen tanks at the germplasm unit in Fort Collins, and also there's another duplicate batch at Geneva, New York, with Cornell University. So that means that germplasm is there. If somebody decides in looking at past records and they don't have that germplasm on hand in their own orchard, that they could get some out of nitrogen, graft it, bring it out of liquid nitrogen and rehydrate it, because it has no water at that point. So you have to bring the water back into it, bring it back to life, in essence, and graft it onto a rootstock, grow it into a plant that would flower and fruit, and then you can make your crosses using those genes.